All right, so we're talking about domain and range. First, we have to have a good understanding of domain range before we can proceed with anything like increasing and decreasing. So I'm going to go through the history of domain and range of what you've learned and when and why things have changed a little bit. So the first thing you learned about is in middle school about actual points. So you first looked at each point. Let me do this in green. So that's 3, 2, so coordinates. 1, 1, -1, 2, -1, 4, and -1, 2, 3, 4, -5, 2. And you learn domain is the x values, all the x values on your coordinate plane of the given function, the graph. Well, this x values, you're just labeling the x's. So -5, -1. There's 2 of them, so we only label 1. You don't. Once you say it, it's already, you're saying that there's a point there. +1 and 3. So that's all the x values. There's 4 x values represented on the graph. Range is the y values. So range 2, 4, 2, 2, and 1. So we'll start at the lowest, always lowest to highest, and domain was the lowest numbers to the highest numbers. So I think left to right with domain. And range is bottom of the graph, so lowest to highest, or bottom to top. And range is all the y values of the graph. So all the y values, looking at the lowest first is 1. So 1, and there's 3 of them at 2, but you just label it once, and that's saying there is a y value at 2, and it looks like the other one is at 4. Don't worry about the brackets so much. So that was middle school. Then we get to Algebra 1, where it's no longer just points. Now there's points, 2 coordinates. Those are the endpoints, but then there's a line drawn in between. And that line, a line represents an infinite amount of coordinates, points put together. So in this case, there's absolutely no way to label every single x value and y value on the graph because there is an infinite amount of points there that all have x and y values. So what we do, the only way you can really describe this is to label the endpoints. So -1, 2, 3, 4, -4, 3, and 3, -1. Those are the endpoints. So with domain, again, it's the x values. And think left to right, because that's the lowest numbers to highest numbers. So we're saying, well, we can't label -4 and then like -3, -2, there's points in between too. There's decimals. So what we have to do is we label from, oh my goodness, we're going to label it from -4. There's a close point there, so it's less than or equal to its x values, less than or equal to 3. So that's saying all from -4 on the graph, from -4 to 3, the graph is there's a line in between. Every x value is represented in here, and in Algebra 2 we labeled it like this with brackets, the equal to. Range is the y values. So the lowest y value is -1. It's equal to because it's a filled in circle. And the highest y value is 3, the highest part of the graph. So it was represented like that when it comes to in Algebra 1, or in Algebra 2, we're going to label it like this, that's interval notation. So that was the lowest y value is -1. The highest y value of the graph is at 3. And that's saying that every number between -1 and 3 is represented in the graph. Now in Algebra 2, we're going further. Now we don't have endpoints necessarily on a graph. So now we have to think outside of what we see. So domain is still left to right. So that's x values. So you're thinking, how far left will the graph go? Well, that'll keep continuing left forever. And how far right will it go? Keeps on going right forever. So negative infinity is how far left it'll go, and infinity is to the right. So domain is negative infinity to infinity. Or you can write it, there's no equal to, because infinity, you can never equal infinity, and negative infinity. And then the range, well, we think how low does the graph go? Well, that'll keep going down slowly, but it'll keep on going down to negative infinity. Let me do that in red. Negative infinity. And then how high will it go? Well, it keeps going up, 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 up to a positive infinity. So again, we'll have the exact same range, negative infinity to positive infinity, or you can write it with inequality notation. Either way. So there's a quick rundown of the history of domain and range. So now let's get to actual let's skip over the definitions. You should have those from previous notes. Domain here on this graph. So domain, let's work it out. So this is left to right. So how far left will the graph go? So I'm just starting on the left side. Well, that'll keep going left forever to negative infinity. So we're going to start on negative infinity. How far right will it go? I'm not going up and I'm not thinking up and down. I'm just following the graph. It's continually going right forever. And to the right on the number line is positive numbers. So that's positive, and it'll keep on going forever, so positive infinity. The range, now let's look at range. Range is how the lowest point of the graph. So the left arrow is going down forever. The right arrow is going down forever. So that's going to go start at negative infinity. What's the highest y value? Well, here there's actually is a top of the graph. The highest y value is at 1. So 1 is the actual highest y value, and there's an actual coordinate there, which is a closed point. Closed point we represent with this means that 1 is included. Or if you want to write it with inequalities, maybe negative infinity is less than y, is less than or equal to 1. Now, increasing and decreasing. Let's talk about that one. We haven't talked about that today. Always start on the left to right with increasing, decreasing. Think about it as like you're walking. Start on the left part of the graph. As you walk, you are going uphill, so this is increasing. And then we go, as you keep going down, this is decreasing. We keep following the graph, it goes down to decreasing. So, and it's always x values, so x values. So where is it decreasing from? So now you're looking at like the domain of the increasing portion and the domain of the decreasing portion. So where is this decreasing from or increasing from? It's increasing from, think left to right. It's increasing from negative infinity. And where does the stop increasing? Because it's coming from the left from negative infinity. Stops increasing at negative 2. And you can put parentheses or brackets, doesn't really matter to me. Decreasing, where does it start decreasing? It starts decreasing at negative 2. And where does it stop decreasing? Stops decreasing. It keeps on going to the right. We're thinking domain keeps going right forever to positive infinity. Don't think, if you're thinking that it's going down to negative infinity, well, we're thinking down is the y values. Up and down is y values. So we're thinking to the right because that's x values. Keep going to infinity. They go to the right forever. Example 2, so domain here. So we're thinking x values, what's the farthest left the graph will go? The farthest, if I'm just stepping back and looking at this graph, the farthest left point on the graph is right here. And what is that point? It's at 3, this is a weird graph, and down negative 2. So that's at 3, negative 2. So the domain starts at 3. There's an actual point there, so I'm going to put a bracket around it because it's equal to 3. And how far right will this graph go? Well, it'll continue right forever, and right forever on the number line is going to infinity. The range, we're talking y values. The lowest y value, the lowest part of the graph is at negative 2. Actual point there. And what's the highest point of the graph? Well, there's no highest point. it just continues up slowly, but it'll continue going in the up direction forever to positive infinity. Now, increasing, decreasing intervals, we got to look at labeling. Label the graph first. Think of yourself, or you're walking on it, or it's a roller coaster. Start on the left, and you're going to go to the right. As you go to the right, the graph will continually increase forever. So this is, the whole graph is increasing. So there is no decreasing intervals. Whereas it start increasing, remember, increasing and decreasing intervals is always labeled with the x values. So we're looking at x value, it starts at 3. If you put a closed bracket there, that's fine. Or bracket versus parenthesis. And where's it stop increasing? It'll keep on going to the right forever, to infinity. All right. Now, what if we have a graph like this, where we don't have potential like endpoints? Or maybe we do. Let's look here. Domain. How far left, how far right? So I'm just looking at the graph. What's the farthest most point, points the graph will go? Well, let's look to the left here. This arrow means it's going to go up and left. So I'm just thinking domain is left and right. How far left will that go? It'll continue to negative infinity. Thinking left, negative infinity. How far, and as we follow the graph, how far right will it go? Well, it continues to go, keeps going right. It'll keep going right forever to positive infinity. Now looking at the range, that's the lowest point of the graph, coordinate of the graph, to highest. Well, this arrow means that it's going to keep going down forever. So down forever, thinking number line, -8, -10, it's going to keep going down to negative infinity. How high will the graph go? Well, let's follow it. That's the local maximum point. It's not the maximum of the graph. That's a local minimum point. That's not the minimum of the graph. And it continues up to infinity. So these are saying the domain is every real number, every number possible, and the range is every real number possible. Increasing intervals. Now let's look at increasing, decreasing intervals. So we have start on the left side, label it, and we're going to go follow the graph. So as it's going down, that's decreasing. And then it has a turn, and going back up, increasing. And then it turns again and goes back down to decreasing. So it looks like we have two portions of this graph that are decreasing, one that's increasing. The next step, what I would do is I would actually label these points. This looks like at 0, -4. And I'm going to estimate this point at 1 point, I will say 3, and negative, we'll just put it at -3, just to make it a little easier. Estimated, I'm not that worried about it. So decreasing, let's do that first since it's right there, labeled. It's decreasing from, where does it start decreasing? Well, this starts from the left side of the graph. It's going to continue from negative infinity. And as it's going to the right, it stops decreasing at 0. So 0. The other portion that's decreasing starts at the x value of 1.3. And where does it stop decreasing? It's going to go to the right forever to infinity. And if you put a u in between, this means that both are intervals of increasing. Decrease, I put that in the total wrong spot. So that should be going down below here. My bad. Increasing is going to go from 0, and it increases from 0 to 1.3. So the increasing should go from 0 to 1.3. All right. Now you try. So this is a good time for you to pause the video and try this problem out. And then I will work the problem out in a little bit. All right. So now you unpause the video. You should have the problem done. And let's work through it. So domain. how far left to how far right will the graph go? The graph will keep on going from negative infinity. That's how far left it'll keep going to the left. How far right will it go? It'll keep on going right. And it's going to keep going right forever to positive infinity. Range. Let's look at the range. I did that in the wrong colors. Range. So both left and right are going to go down to negative infinity. So it's going to start at negative infinity. Doesn't matter if both of them do, one of them do. You just need one part of the graph. Remember back to middle school when you had x values that were, or y values that were repeated, you just needed one. You just write one of them down. So this is the y values go down to negative infinity. And as you follow the graph up, the highest coordinate, the highest y value is at 0. That's the highest point of the graph. There's no other part of the graph that's higher than that. So it's at 0. And then it's a closed bracket because it's actual closed point there. It's actual coordinate. Remember, a graph is an infinite amount of closed points put together. Now looking at increasing, decreasing. So let's label increasing, decreasing. Remember, you're walking from left to right. So this is increasing. At the peak here, at -2, 0 is where the turn is, and it'll turn, and you would go back down to decreasing. You could also think of it as a roller coaster. So it's increasing from negative infinity, because it's coming from the left, to -2, and it's decreasing from -2 to the right forever to infinity. All right, let's try out another problem. So another you try. So pause the video, work this problem out, estimate the points. So estimate the coordinates. And when you're done, unpause the video and I will explain. Okay, so domain. Domain is x values, so how far left will the graph go? Well, it'll start at negative infinity because that arrow means it'll keep going left forever. How far right will it go? Well, it's continually going right as I draw the graph or trace the graph. It's going to continue to the right slowly, but it's going to continue right forever to positive infinity. Cool. Range. What's the lowest part of the graph? Well, this arrow means it's going to keep going down forever. And as we, again, trace the graph, that's a local maximum point, and then it's a local minimum point, but that's not the maximum of the graph. The maximum of the graph means it'll keep on going up forever. So this started at negative infinity because it's going from the lowest point of the graph is down below, bottom. The highest point is positive infinity. Increasing, decreasing intervals. We have from left to right, increasing. Then at this turning point here, it goes back down and decreases. And then turns again and goes back up to increases. So now let's look at, I would actually next label these coordinates. So that's at 0, -4. And this is at, let's estimate it at 1. Well, it looks like a 1.3 again, about whatever your number is, I'm sure you're fine, as long as it's somewhat close to that. And we're only worried about x values. So I'm just concentrated on x values, not the y's at all. Increasing, when you say y values, that's labeling increasing and decreasing. That's low. That means it's going up or down. So we're labeling them with x values. So let's first look at the increasing. It's increasing from negative infinity because it's coming from the left. It's coming from the left, and how far does it go? To 0. And then there's another increasing at 1.3. And where does it stop increasing? To the right. It'll continue to the right forever to positive infinity. Put a union in between, stating that they're both parts of your increasing intervals. Decreasing, it only decreases from 0 to 1.3. All right. That'll be enough for today. So hopefully that helps you out. If you want to go back and look at your practice for 1B, you're more than welcome to. And I hope this